All right, welcome to lesson 6.2. This lesson we're going to multiply and divide radical expressions. And this one actually takes 3 days. There's a lot going on in this lesson. There's kind of some complex ideas and stuff, but the problems will look like some of the ones you see down here. This video we're going to start with the multiply part, and then along the way you'll also have to simplify. So actually we're going to start with the simplify part. That's actually one of the harder concepts in this chapter. So just as a review problem, if you want to jot this one down, we've done this with square roots before. So the idea was if you had a square root, you simplified it by breaking it into two roots that multiplied to the number underneath the check mark called the radicand. All right, and you wanted at least one of them to be a perfect square. So for 40, you think like of our perfect squares, 4, 9, 16, 25, etc., which ones divide 40 evenly? And so the one that works here is 4. So we split it to 4 and 10 because that multiplies to 40. And then the square root of 4 becomes 2. Sorry for the poor handwriting. So we end up with 2 times radical 10. And we're considered done if the number under the check mark, if there's no other numbers that'll evenly divide it, no other perfect squares, then we're done. So this is it's equal to radical 40, but it's just a simplified version. All right, much like you might simplify a fraction. If I simplify 2/4 into 1/2, it's still the same value, it's just simplified. Right, so all we're going to do now is start to do this with cube roots and fourth roots and stuff like that. So what'll matter is there's this chart, which in class I usually print it off. For you guys out there watching this on the internet, you might have to copy it down. So here's your value of x, and then here's your squares, cubes, and fourth powers. And generally, I just make the table go up to, it looks like I have mine going to 12 squared. And I think you don't need anything beyond that. There is occasionally an x to the fifth question. So I sometimes should add that. There's an x to the fifth. 2 to the fifth is 32. And so kind of how you read this is if I have a fourth root of 16, that is 2, right? The cube root of 27 is 3. It'll make more sense kind of as we go and do it, but I would have this chart copied down as best you can when you do these questions. So again, here's one more square root one. So see if you can figure this out. Which perfect square number will work for 48? What evenly divides it? Okay, and the reason why I put this one in here is there's actually two. 4 divides it, and so does 16. So you want to use the biggest one possible. So when I figure it out, I start and go backwards and say like the first one that's below 48 is 36. It doesn't divide it. 25 doesn't divide it, but 16 does. So we're going to make it into 16 and 3, and then it becomes 4 radical 3. If you had used 4, it's not wrong. You just have to split it twice because you split to 4 times 12, and then you're not done. 4 becomes 2. Square root of 4 becomes 2, but then 12, there's another perfect square of 4 that you can pull out. So you'll get the same answer, it's just a little more work. So you want to use the biggest perfect square possible. All right, so let's try a cube one. So if you have a cube root, you're going to use your x cubed column here. And it's the same concept, except I'm going to make 2 third roots instead of 2 square roots. Okay, and then I'm going to check. So 64 is too big. All these are too big. Take 27. Does 27 divide 54? And it does. 27 and 2. Okay, so now when I do a cube root of 27, is what we did in the last section. You can either type it in your calculator or use the chart. Just go across the chart and say, oh, the cube root of 27 would just be 3. 3 times 3 times 3 is 27. So much like before, we had the part that came out perfect times the part that's not perfect, just like we did up here. All right, so we get this as our answer. All right, 2 more for you to try, a third root and a fourth root. All right, and again, you're going to use the x cubed and the x to the fourth on these. So pause the video and see where you're at on these. All right, cube roots. So I'm going to make it into 2 cube roots. And for the cube numbers, I'm going to start 216 is the first one that could work, but it doesn't do. And I can show you real explicitly if you want here. What I'm doing is I'm doing 250 divided by 216, right? And I can kind of tell mentally, but if you can't divide it and that doesn't come out evenly, then go down to the next one and try 125. I'm going to do 250 divided by 125. Okay, and since that came out evenly, I can stop. Right? If it didn't, I would just keep dividing by the next one down, but that one worked. So it's going to split to 125 times 2. And then the cube root of 125 going across is just 5. So I get 5. The cube root of 125 is 5. And then a third root of 2. Okay, and then for 164, now I want to use my fourth powers. Okay, and so there's actually not that many, so it's easier in a way. So the only ones that are less than 162 are 81 and 16. And again, I'd start with the 81, and that does divide it evenly. So we break it into 2 fourth roots. So the fourth root of 81 and 2. 81 times 2 is 162. And again, I get that by doing 162 divided by 81 on my calculator. And then a fourth root of 81 is just 3. So I get 3 and then a fourth root of 2. Sorry, that looks weird. I have a hard time writing that here, but it should be 3 times the fourth root of 2. All right, so just keep working through examples. Get a little more complex. Oh yeah, actually, sorry. What comes next is we're going to do this with variables. So we just did it with numbers. So with numbers, one more time looking at it, if I have a square root, I make the perfect part and the non-perfect part, like 25 and 2, and then you have 5 radical 2. Okay, so we learned about in the previous lesson, if the index divides the exponent, you're all good. So like x to the ninth divided by 3 is x cubed. Perfect, you're done. Okay, but this lesson we're going to start to do what if it doesn't evenly divide. Okay, so if you look here, this is like an index of 2 because nothing's written there. And that doesn't evenly divide 5. This 3 doesn't evenly divide 10. And 4 doesn't evenly divide 7. Okay, so if it doesn't evenly divide, we are going to do that just like we did with the 50. We're going to do a part that is a perfect root and then a non-perfect part. Right, so for this fifth, x to the fifth, I'm going to make 2 square roots. All right, and what I have to think is, I want to lower this, right? So like x to the fifth, you can split it to like x to the fourth times x to the first, because you'd add the exponents. So that is equivalent to this. You could split it to 3 and 2. You could split it to 2 and 3, etc., etc. Okay, so we're going to break up the x's, put some of them here and some of them here. And we want the highest number here that is divisible by the index 2. So out of all these choices, I just look here, this 4, 3, 2, right? I want it the highest one that is, and so 4 actually works. So I'm going to do x to the fourth and x to the first. Split it with 4 and 1. All right, and the point is, just like in this example, square root of 25 becomes 5. Now the square root of x to the fourth, that divides out, so we get x squared. And then we have the leftover square root of x, just like we did here. We had a leftover part. Right? So I'm kind of running out of space on this. So I'm going to erase some of this, sorry, but I'm going to do some other examples. All right, so y to the 10th, the third root of that. Again, this exponent does not divide evenly with the index. So I'm going to think I have 10 y's, and I can split them to 9 and 1. Multiplied together, 8 and 2. 7 and 3, and I don't really need to list them all because I've actually found the one I already want right there, right? 9 is divisible by 3, so I'm going to make 2 third roots, and then I'm going to put the perfect part here, so I'm going to put y to the ninth because now it'll divide out, and y to the first. So again, I want the highest one that is divisible by 3. So sometimes when I do this, I just start at 10 and start counting backwards, 9, 8, 7, until I get one that is divisible by 3. Right, and here I just counted back once and I got it. Okay, so now this will divide out evenly, giving us y cubed, and then we have a leftover third root of y. Sorry about the discombobulated work here. Let's not do that. Let's undo this. I'll put this here in red. I'll save the work. And then do this other one a different color maybe. Okay, so again, you can list them out like I have on these other two questions, or I just count backwards. So I say 7's not divisible by 4. Go backwards. Is 6 evenly? No. Is 5? No. Is 4? Yes. So I go backwards until I find one that is evenly divisible by my index. Okay, so that helps me figure out that x to the 6th, x to the 5th didn't work, but x to the 4th will. And so I'll have 3 in my leftover because I have to add up to 7. Okay, so now these will cancel out, giving us just x to the 1st, divide it out, and then we have a leftover 4th root of x cubed. Okay, and that's our simplified version, right? And again, think back to what we did with numbers, right? This looks a lot like numbers. You have the perfect part and then the leftover part. Right, so we're just doing that same thing except with variables. All right, and this concept is pretty complex and the most important probably thing we learned today. So I'm going to give you one more, pause the video and see how you do. This will be a good check to see if you got this or not. All right, so 8 isn't divisible by 3, so I've got to split it up. All right, and I'm really discounting backwards. I'm saying I could do 7 and 1, but 7's not divisible by 3, so that's no good. So I could try 6 and 2. That adds up to 8, and 6 is divisible by 3. Right, so that's how we want to split. We want to do the third root, put 6 of the x's here, and then to make them add up to 8, we have 2 left over. And so this now divides, giving us x squared. And then we have a third root of x squared left over. That's our simplified version of what we started with. All right, so here's putting it all together. So now we have one that has both a number and an x to the 5th. Right, so it has an exponent part. So we're going to split it, and I usually say there's like the perfect radical part and then the non-perfect, because sometimes I call it the leftover or dumpster fire. These are like the kids, like when Mr. Westphal goes to the middle school dance and no one wants to dance with them. These are like the leftover ones back here, the ones that didn't get picked, the non-perfect stuff. Okay, so it's just doing what we've done, combining the last two things we talked about. So like take the 54 and take your chart and say what cube numbers divide 54. So you look at the chart, and I think the one that works is 27. So we do 27 and 2 in our leftover. And then x to the 5th, again, we're going to split it. Like 5 isn't divisible by 3. So we could split it to 4 and 1, 3 and 2. Basically, we want to go until we find one that is divisible by 3. And it looks like this second one would work. So I'm going to put x cubed here and x squared in my leftover pile. All right, and then these are perfect. So they come out when you do the third root of 27, that's just 3. And then this exponent divides with the index, so we get x to the 1st. And then we have our leftover pile of 2x squared in the back. All right, let's see if we can get at least one more example before this ends. All right, so again, jot this one down, pause the video, give it a shot before continuing. All right, so I'm going to make 2 third roots, and I'm going to go to my list of perfect cube numbers. Normally I have it written up on the board, but I copied it down here. And so I'm going to start with 125. It doesn't evenly divide 128, but 64 does, so I can put 64 in my perfect pile, meaning 2 left over. 64 times 2 is 128. And then the exponents have to add to 7. So 7 isn't divisible by 3, so I'm going to put some x's here, some here, and then count backwards. So if 7 doesn't work, does 6? And 6 will, so I'm going to put 6 there and 1 in my leftover because they add to 7. And now the cube root of 64 is 4. Divided out, 6 divided by 3 is 2. And then we have a leftover third root of 2x. Okay, and I ran out of time, but I'll do some more examples on the next lesson.